just tell me to take
Alright, fire
over?
photo.
I can do mine.
Alright, everyone, get off the stage. Let's get started. Find a spot where you can see, but be on this carpet. Who just flew away? Come back. Yeah, stay here for the lesson.
Talk, you gotta shut up, okay?
My bad. Let me mute myself.
Alright. So, oh, actually, let's introduce ourselves first. Alright. Hello, everyone. My name is Snug. I do circuits, and I make maps and stuff. Do circuits in the maps. Super useful. I'm the head teacher of the class. So, you know, hopefully you learned something. If not, it's kind of on me. Yeah. You have a question?
Yeah. For some reason, when I go into my maker pen, it just like distorts.
I couldn't tell you why.
Distorts how?
You want me to like leave and rejoin?
Yeah,
That
you
might
could.
fix it.
Yeah. Alright, who wants to go next? Oh, wait, no, we have another question. What's up?
Do you have a question, Crypto?
Alright. You might be muted. Alright, who wants to go
We'll
next?
come back if you still have a question. Hey guys, I'm Will Chill. I'm one of the co-teachers. This is my third semester teaching. I've been using circuits, CV2 specifically, which is what this whole class is about since it came out, I think in like 2021, and CV1 before that. We won't be covering CV1 in this class, fortunately. Yeah, all of us, all your co-teachers know a lot about circuits, so if you have any questions, just hit us up on the Discord.
Hello everyone. Oh, sorry. You're good. Alright. Hello everyone. I'm Ducky, doing circuits ever since I came out in CV1 for a long time. Was the head teacher, but you know, been here since the very start, so I got some experience of CV2 under my belt. Happy to see you all.
Adding on to what Doomman said about recording, if you miss a class, like, don't worry about it. You can always watch back the video, but also be mindful of the camera. Like, you can see it right here. It's this like blue thing. This is the streamer cam point. Make sure you're not blocking it, because then for people who are watching the video later, I don't think they want to just see the back of your head. So, be mindful of that.
Quick question.
Yeah.
Which one of y'all made me this?
It was Doomman.
Okay, you my favorite
Your
teacher.
question, Crypto?
Is my mic working, first of all?
Yeah, we can hear you.
Yeah,
I was
yeah.
gonna ask, do you need the maker pen to actually be able to see the circuits?
No,
We should have
will not.
circuits on for everybody, so you won't need it.
If you
Although when we
if
go
you
over things, you're
cannot-
welcome to take out your maker pen and work along, like out on the carpet.
if for some reason you're not able to see the circuits, look at your maker pen and make sure that show circuits is on in the top right corner. If you can see the streamer cam point or this chip, you can see circuits.
Okay, then I can see both, so that's good. Nope. Keep accidentally doing the size.
Also, I
have a question,
message
Uncle?
you just to apologize that I might light out like 100 times.
No.
Hey, real quickly, what does that do?
So that is a screen share component, and we use it to like show close-ups of things that we have up sometimes. So like if I'm like going over some chips, Dootman could, yeah, he's showing you how it works now. It just shares what's on a screen so we can get a better view and show all of you.
This will show what it like. This is the point of view of the video. So later, if you're not sure, if for some reason you're in the camera and like blocking the whole thing, just you could look over there.
So like this?
Yeah, that would be in it. Are we already recording? We're already recording, so that was in it. If you have a question, please raise your hand. Don't interrupt, but we will call on you, like, pretty much as soon as you raise your hand. Does anyone want to add anything, or can we get started?
I think we're good.
Alright, let's get right into the chips.
Yeah, we had a board of chips.
No. Alright, you're banned. You're banned.
Did I hear a question?
Come here, big back.
Yeah,
Hey,
yeah,
you're
what's
my
up?
food again. I'll fuck you up.
I'm sorry, I didn't know if you could. Are we just gonna like go over?
Come here, Louis, give me that food.
Last
Let me
semester,
snatch
or
that.
vectors we didn't, or is that like something?
Yeah, I'm gonna do a
more
360 with
advanced?
Go over what?
I'm actually in class right now.
Oh, a cosine? Probably
I'm
not
actually in
specifically.
class right now.
I can explain it how it works later though.
Because I'm in
Okay,
class.
so since this is obviously the first lesson, we're going to be going over the very basics of circuits. So you all probably know what circuits is, but just to be clear, it is a programming language, just like any other programming language. To explain some of the basics, it specifically is
Yeah,
a
not
graph-based
actually.
programming language.
Oh, yeah, so
This
you
means
know-
you build up logic by creating a graph. What is a graph? So you might have heard of a graph as like a line on a plot with the x, y axis. That's a different kind of graph. Don't think about that. These kind of graphs is like we have chips. Chips are also referred to as nodes on the graph, and we have edges. Edges are the wires. So if I hook something up real quick, let me clone one of these to show you what a wire looks like. The wires are the edges that just connect between nodes, and that's how you build up logic. We're about to cover this, but the two main types of wires are executions. These do things. If you have an execution wire, that means it will do the thing up to this point, and then it will follow the wire down, going in a straight line until it gets to the end of the execution wire. The other kind of wires are data wires. So this is just how you calculate values. You can think of XX as doing things, and datas are like getting values. As any other programming language will have, or at least most of them, we have types in circuits. So these are like all the major types. There's a ton of types, like every component, like a light or a button or whatever. Those are all their own types. These are the main types.
Orbital.
These are referred to as primitives. They're just basic data, true or false, numbers, text. They just make up like they're just like fundamental types of information. And then there's some more types, like we have player, some Rec Room specific types, and all of these have like chips that work with them, specific chips that like do things with the data, and that's pretty much the entirety of how you interact with Rec Room by using circuits. You build up logic, and it does a certain thing, and then you just have your graph up, and it does what you want. There's lots of different ways to do it, and we'll cover all of that throughout the next 6 classes. Do you want to cover the chips, Snug?
Yep. Alright. So, wait, did you go over what each port does, or just explaining the
I
overall
didn't go
thing?
over any specifics, just the basics.
Okay. So then I'll do that. Orbital, can you stay
yeah.
behind the camera?
Sorry, I didn't know.
Alright. So, as Will was explaining, this is one of the most important like port types. This is a execution. Think of it as power for everything. If you want something to run, you have to give it power. So, yeah, just keep that in mind. We'll give it. Orbital, can you mute your mic?
Oh wait, I wasn't. Wait, I thought I had. I thought I was muted.
You're not.
Oh, sorry.
You have a question?
Yeah. How would we, like, if I make a shape like that,
Mhm.
how would I be able to, like, store that as a value?
My cookie, bitch.
Like, how would I be able to like make that disappear, reappear, and so forth? With
Uh,
circuits?
you're not able to make stuff like appear and disappear yet. Although we'll get more into that in a future class, I think. Probably our vectors one, right? I don't know, something like that.
The short answer on how to get access to objects through circuits is usually with tags, especially if it's a shape. But we'll cover all that later, so we'll get to it soon.
Yep. Any questions for the execution? Or it's a question.
I don't have a question, but I did want to add on.
Okay.
I'd usually like clamp it to something that can be like, per se, like set position, or like you're able to set its position, like way below that.
That is. Oh, you're saying to make it appear and disappear?
Yeah.
Yeah, if you wanted something to appear or disappear, you could just move it far away.
Yeah.
But it's not actually gone. Yeah. So no questions for execution for now. Okay. Next up, we have a Boolean. This is pretty straightforward. It can have two different kinds of values in it: true and false. It can't be numbers. It can't be text. It can't be
Just true
any.
or false.
It's only true or false. It is pretty useful, and we'll get into some use cases. Next, we'll go to. There's a weird order. I'm actually gonna go to integer, and we'll come back to float. An integer is just a number, a whole number specifically. It cannot go into decimals or nothing. So integer is a whole number, not text, not a name. Speedy.
What I have heard is when you use the int and there's like too much numbers, it will go to negative. Is that true?
Well, integers can be negative numbers. They just can't be decimals. Will seems like he wants to explain why that happens.
So
Like it goes up to
both
1
ints
billion.
and floats. Yeah, these are both 32-bit integers. If you want to know how like it works like on your computer, they're 32 bits. Bit is just true or false. Doesn't really matter for circuits.
My cookie
But
wants to
internally,
fuck you up.
so that means like the way the data is stored is it's like 2 to the 32nd power, like actually a -1, is the maximum value you can have. And the very leftmost bit is the sign, like 0 for positive or non-negative and 1 for negative. So if you go too high, the maximum is like 2.147 billion. If you get past that, there's no more room to fit those numbers because it's like a finite amount of data that you can store, and it'll just add
Yeah.
1, and it'll like flip over. It's called integer overflow, and it'll be the lowest number it can possibly be. But unless you're dealing with like billions of numbers, you should be okay.
Oh, okay, I got you.
Yep. All right. Next we'll go over floats. They're also. Oh wait, hold on.
You have a question, Orbital?
Oh my bad.
Yeah, so one time I was told that if you use like float variables for like clicker games, you could go above the 2 billion limit.
That's sort of true. We're getting into the very specific details of how like number specifications on computers work. But basically, it's true. Yes, float can go way higher than 2 billion, but you start to lose precision. So if you have a really big float +1, that won't actually be 1 higher. But could potentially be the same value. This probably won't really matter for this class. If you're using a clicker game, I'd still recommend using an integer.
Oh.
All right. This is a float. It also only holds numbers, except it goes into decimals. That's solely difference from integers. They're slightly less precise than integers, so you gotta think of your use case. No, we'll teach that in a later class. Next up, we have strings. Strings are text value. You can put numbers in them, but they're not like perceived as like a number, place, or whatever. Like think of a player's name as a string because it's text. All right. Next up, we have vector threes. they're for like position and stuff, you know, like if something is at the very center of a map versus like 2 meters higher than the center, the number will be different. We have a whole class specifically about vectors, and they're really cool. So make sure you show up to that class. Next up, we have Rec Room Object. To whoever was asking that question about how do you reference a specific shape, yeah, that shape would be a Rec Room object. The port you would get from it is a Rec Room object. It's not going to be any of these ports. It's going to be a Rec Room object. And much like how you would reference a Rec Room object with this, there's a player port. This is for players. You know, you can put a player in it. You can put me in this type of port, or someone else. You have a question?
Can we connect the same the same ports?
What do you mean?
Like for example, can I connect a vector 3 to a Rec Room object and from a Rec Room object to a player?
No.
So that's actually a great question. All the ports are typed. You'll see they have different colors, and generally you can only wire ports, like ports of a type, to another port of the same type. There is kind of an interesting exception to this, in which like port types, or you can think of them as hierarchical. So like these do not have a base type. These are just types on their own. There's no types that derives from them. But however, the typical exception we see in Rec Room is the Rec Room object type. So this is Rec Room object. This is literally just any type. And I mentioned earlier that we have things like buttons and lights. Those also have their own type. But if you think about it, like a button is also a Rec Room object. So if you have like a light port that refers to a light in your room somewhere, you can wire that into the Rec Room object port, because a light is a Rec Room object. However, a Rec Room object is not a light. A Rec Room object is just a Rec Room object. It might happen to be a light, but we don't know necessarily from the information that is a Rec Room object what specific kind of Rec Room object it is. So it's kind of like it actually is like a hierarchy of like base types, and you can only wire up ports that are compatible. If it's not compatible, it just won't let you connect it. So it's pretty easy to figure out what connects to what.
I hope that didn't confuse you. I have a few questions. What do you need? We'll start with crypto.
I have to BRB real quick, so. 'Cause
Oh yeah, you guys are allowed to just leave whenever. You don't have to tell us. Don't
Yeah,
worry
it's all
about
good. And if you want to see what you
Okay.
missed, it's going to be on YouTube shortly after the class.
Okay, that's good.
If you are leaving,
If you go
please
AFK,
go to
please
your
do it,
dorm
like, in the back of
first.
the class.
Okay. Yep. He.
What's the
Okay.
channel? The channel name?
We'll post it on the Discord.
Okay.
Okay.
Yeah, you guys will see on the Discord.
should've known
There's
telling this class.
announcements, chat, then event photos, and then event videos. Speedy.
So there was a difference between when I put like numbers in the float variable, it'll be like actual numbers like 1, 2, 3, and 4. But when I put numbers in the string variables, then that'll be a text number, but not a number.
Yeah. that's
Yeah,
exactly
there
right.
are ways to like convert it or whatever, but think of things like not everything could convert. For example, like I couldn't turn a Boolean into a player. Like that connection doesn't make any sense. There are like some ways where you could select a specific player with a Boolean, but like you couldn't directly convert that. But you could convert something like a float to an integer because they're both numbers, you know, or a string that has numbers to a float or an integer. You know, there's ways to convert stuff. I think when we'll cover specific chips for each type of port. Well, the way to convert them will be in there too.
This is gonna be a long class.
We got to color. It holds colors. It's not numbers, players, or nothing. It's just colors. Yeah. And then we have quaternions. They're over here, and they're really confusing, and they're kind of like made up numbers for rotation. We're not gonna go over them in this class. So, but they're just here so that you know it's a thing.
Basically,
question?
the express rotations. The specifics don't really matter. But if you want to set a rotation of an object, there are high-level quaternion chips you can use to like work with more reasonable information to just get that in the format you want. Yeah, what's up,
But
Deagle?
don't.
So I know this is probably a dumb question, but just changing the color of the chip, it doesn't mean anything, right? It's just for
Oh
organization.
no, if you
No.
recolor the chip, it's just purely cosmetic. It has no impact on
Okay,
functionality.
okay.
The using color is good for organizing your chips and stuff. And also don't worry about like not being able to set the rotation of your like objects and stuff. You can actually do rotation with vectors, and we will go over how to do that. So don't worry. Don't worry about it. Were there any questions before we move on to variables? Nope. Okay. Let's start. Who wants to do variables?
Yeah, I can get that. So
Okay.
for pretty much all these types, not every type, but the major types, they all have a variable. And you might be wondering what is a variable, especially if you've never used programming languages before. If you have used a programming language before, a variable is exactly the same as what you'd see in a traditional text-based language. It stores a value, and variables all have types because the value you're going to be storing has a specific type. So it makes sense that it would have to be in a variable chip of the corresponding type. So you'll see we have Boolean variables, float variables, integer variables, string variable, vector variable, Rec Room object variable, player variable, and color variable. And you'll see there's a few ports on these. There's 4 ports. So in terms of inputs, there is the execution input. There is the data input. You'll see the data input matches the type of the variable, which makes sense. You can't wire like a float into a bool variable, for instance. And then output is the same. There's an exec and like the data port of the type. And the way you use this, if you want to set a value of it, like if I were to hover over this output here, the data output, that will tell you what the current value of the variable is. So if I set this bool variable to true, and I hover over this, it'll tell me true. If I set it to false, it'll tell me false. But the way you set it is kind of similar. You run the exec input, and then at the time that you run this input, it will set the internal value of the variable to whatever you have hooked up to this. So you'll see that some ports actually just have a thing hanging out of it. Like this just says true, this says 0, this says 0 as well. This is an empty string. Whereas some objects don't have it, like Rec Room object, like there's nothing here. That's just a little convenience that Circuits as a programming language provides to have a default value. Like I can just like click on these and change it. Like if I click on it, so somebody's currently selecting each. Oh, there we go. So when I click on it, it'll change it to false. If I click on the input for floats and then look at my menu, bools are really simple. There's only 2, so it'll just switch between them. But if I click on something like the float, there's a little menu where I can actually specify a value. Yeah, so if I take a value and then I run it, it'll set it to whatever is there at that time. The default value case is very simple. It's just grabbing that directly, but I could conceivably have a whole system of circuits hooked up to that will like calculate the value that I'm going to set it to. So like for instance, if I wanted to set it to like if there's only one person in the room, it'll be true. If false, if there's more than one person in the room, it'll be false. I would get some system that would say like, okay, get all the people in the room, get the list of that, get the length of that list, see if it's equal to 0, and then that would output a Boolean Boolean value, and I'd hook it up there. And yeah, that's pretty much the basics of how to use variables. There's a few extra options that if you configure it, you'll see on the chip. So this might be helpful if you spawn in a variable chip. Just like search any variable and just spawn one in. Actually, let's do bool variables because they don't all have the same options.
Everyone grab your maker pen and place down a bool variable.
You said a boolean?
Yeah, a bool variable. It should have this name.
And you might notice BOOL for short.
Yeah, stands for Boolean. And you might notice as you put them down, they will have new names and a bool variable and then some number. And the reason for that is because variables kind of have some interesting functionality where if if I were to clone a variable, so these both have the same name. They're both called bool variable. So if I update the value of one of them, the other one with the same name will have the same value because they are referring to the same value. Variables kind of track values by name. So if they have the same name, they're the same value. If they have different names, they will have different values, and they will just update automatically to all other variable chips of the same name. So related to that, if you configure it, you'll see there is a field to rename it. So I can just type in whatever name I want. Just name my bar, and there's a submit button. Make sure to hit that, or else it won't update. And you'll see that it has actually changed the name on the chip. Given what I just said, you should keep in mind that this will now be a distinct variable separate from this one. So the values will no longer be linked. Additionally, you'll see some settings on it. If you configure it and scroll down a little bit, there is synced. We're going to have a whole class on networking, so don't worry too much about this now. But basically what that means is if you turn synced on, the value is guaranteed to be the same for everybody in the room. Like if you make a change, that change will get pushed out over the internet to everybody else in the room. The default actually is that it's not synced, which means that if you make a change to this, then it could have a different value on your local like instance of Rec Room running compared to somebody else in the same room as you. And if they make changes, they'll see those changes for themselves, but it won't come back to you. It might be kind of confusing, but we're going to have a whole class about it, so don't worry too much. What's up, Breaking?
Could we use this with the if chip?
Yeah, exactly. When you have an if chip, I'll take one out right now. That is used pretty much like it just operates directly on a bool. So you see it has an input, two outputs, and a condition. This is an extremely useful chip for controlling the execution flow of your circuit graph. So basically the way it works is you run it, exec input here, you have it connected to a bool. If the bool is true, it'll only run this top output, the then port. If the bool is false, it'll run this else output. It'll only run one of them. You'll probably use that one a lot.
Is it also the same for like over those chips? Like I can't connect the same ones if they're different names. Like for example, I can't connect a boolean to a float. Is that true?
Yeah, that's accurate. Boolean floats are different types, so it won't let you connect them.
That will apply for everything. If they're different ports, you can never connect them. You can only connect the same port to its matching type. You'll never be able to connect them otherwise.
Okay, so if you configure the chip, you'll see a few options below synced. There is for one that's cloud variable. Basically what turning it into a cloud variable does is, first of all, you can only have cloud variables like out in the room. If they're in a circuit board, you can't be a cloud variable. We haven't told you what a circuit board is yet, but we'll get to that eventually. So if you turn that on and it becomes a cloud variable, it'll also apply to every other variable with the same name because they're the same thing. But then the main bit of functionality that gives you is if you set it to a value and then leave the room and then you come back, it'll remember what it was when you left the room and it'll have that same value. So if you want to make a game where things save, like if you have some XP system where you do some accomplishment and you get some XP and you want it to save next time they come back, you'll want to store that in a cloud variable. Note that means that it will also not be synced, because it's a specific value for each player. So it won't be like copying over to everyone else in there. It's just your personal value that saves when you leave and come back. And then below that, there's a value port. This is just like what the variable will default to. So bool is true or false, which is why when you look at the value, it's a toggle. If you toggle that on, then when you, for instance, load into the room, this will just by default be true. You can still turn it on or off like usual, but when it starts out, it'll be true. Similarly, the other variables have their own values that match their own types. So the float will have a field where you type in a floating point number. Integer will let you input an integer number. String just is a text field. And some of them don't support defaults. Like I don't think these three do. Just some technical reasons it's complex to add, as well as players like aren't persistent in the room, so it's not really a good way to do that. Colors do have their own value. It's kind of the same UI as when you recolor things. Does somebody have a question? Yeah, what's up, Frog?
Not. I forgot what it does, even though it's like the simplest thing ever.
Oh, right. So this is a pretty simple chip once you know how to use it. It just takes a Boolean input. Let me rotate this around so people can see it. You have it selected. Can you turn it around? Okay, there you go. It takes a Boolean input. If it takes true, it'll output the opposite, so it would return false. If you give it false, it will return true. It just inverts the Boolean we'll go over like Booleans and floats and integers in tomorrow's class. Oh, and strings. Yeah. What's up, Speedy?
So from chips, like the list create will be the only chip that can support like almost all of the executions except for the execution chip. Like I can just group bool variables.
Yeah. So these are data types. And data type, like if it's any data type, it won't work with an exec type because that's not a data type. But you will notice. Let me put one down because this is a good point to cover. So this is a list create chip. We're going to cover lists more later, so don't worry too much about what it does. But you'll notice that the ports on it. Oh, today? Okay, we'll cover it later. So these ports are white, and you might be wondering, what is a white port? Why does it not have a specific type? If I hover over it, it'll say any. Yeah, any on the types. That means it supports, like it can support any type. So like as the name would imply, I can just take whatever I want and wire it in. And once I do that, and then I hover over it, it's no longer says any, it's no longer white, it's now blue and it says float because it has become a float port. And the way it's set up is that, like, at least on this chip, all the inputs are any, but once you bind one, once it knows which one it wants to be, like I've connected a float port, all the other ones are the same. So these have all also become float ports. And like if you're thinking about a list, it can hold like whatever type you want, which is why it supports any. It doesn't matter what type you're giving it, as long as like every input matches. It can just take like a list of floats, a list of lights, a list of buttons, a list of strings, and then it'll make a list of that type. So this, you'll see that the output is also blue. Yeah, there's a few chips that work on any or some combination of specific types. They're pretty useful. They just work generically across different types. And I think that's pretty much everything for variables. All right. Do we have any questions about variables specifically?
I'm the one that should be paying attention.
Nope. Okay. Oh, I see one question. Oh no. Are you not raising your hand, Sandy? Sadie? No? Okay. Default?
So, okay. When it comes to variables, because I've made one with time before, that'll appear above your head, and I saved that as an invention, and for some reason it didn't save, even if it's just set in there.
That seems a little unrelated, and I want to stay on track. But feel free to ask us later about it.
I
think I know what you're saying. Actually, did you take a variable and you ran the exec input to set it to a value, and then when you saved it, it didn't have that value in it?
I think so. Yeah.
Okay, so that actually is like an important point to cover here. So generally throughout all of circuits, like not just for variables, but like for everything, if you make a change to something, just anything in the room that is changed as a result of circuits that you've run, when you then either save the room or like copy and paste that object or like save it as an invention, those changes will not save. The only things that save are things that you change with like as a result of doing something with your maker pen, like as a creator. Like if I, for instance, have this button and I run a chip to set the text on it, and this is running from the chip, that won't save. The only way I can change the text is to configure it and type in the text there. So that's probably the issue you were running into their default.
All right. everyone, you can delete your variables. You're not going to need it for now. This next thing we're going to show you is just like how you can use execution, if it wasn't clear before. So I'm going to hook up this button to this beacon, and you can see there are these outputs on a button, such as when someone presses it or when someone releases it, and then if it's currently being pressed. And on a beacon, there's inputs like enable the beacon, disable the beacon, set the height, and set color. And then these ports are just like when you run that. So can anyone guess what will happen when I click this button, specifically when I release it, Speedy?
Alright, so while you're pressing the button, it'll set the beacon to on, but when you release it, it'll just be completely off.
That is correct. So when I press this first thing is running and enabling the beacon. It was already enabled. But then when I release it, it will disable the beacon. And now you can see it turned off, right? It's super simple. Does everyone understand why that works? Yep. Okay. Crypto.
Yeah, it works when it detects when you press the button, which will make it so that the begin's like, hey, you press the button, so I'm gonna just enable with that press to the
Yeah.
the enable and
Speedy?
then opposite for off.
Okay, so how
You had a question.
so how that you did that is because when
Oh, no, you don't need to explain. I just want to make sure that you all get it.
Oh, okay.
All right. So now we're gonna go over like where are these ports like even getting their power from, because you're actually able to like remove these on a button. If I configure the chip and I go like scroll down, if you guys want, you can place your own button and follow it. You don't have to. If I configure the object board on this button, this object board is specifically linked to this button, and you'll see a little like yellow connector. If Dooman wants to click it. Oh, did he click into the button? Oh, great. Oh, that's great. All right, you guys can see over there. But Dooman, can you configure this button, the chip, and show us what's inside? Give him a second.
I should explain a bit first what like boards are. So the button is a type of component. So is the beacon here. So is everything else that you like interact with in the world through circuits, pretty much. Shapes are not notably, but they all have object boards. Like the components all have object boards. It's the bit of, it's like the chip that's connected to the object with the little yellow line when you have it configured. And it is linked to the object in some key ways. Firstly, when you open up the board, there will be a self chip inside of it, which we're going to show you in a second. But that self chip refers to the button, like access through circuit. So like you hook it up to something, and it is a port that gives you access to the object itself. Secondly, there are events. We're going to cover events later. But like for instance, that's how you know when the button is pressed. You hit the button with your finger or whatever, and then Rec Room sees that, and they run a circuit inside of it that will convert that into an execution. I think we're going to cover this in a second. Additionally, there are circuit boards. These are very similar to object boards, except they are not associated with a component. They're kind of just standalone little boards that like they're very useful for separating your circuits out. Like if you have some bit of circuit logic that does one like objective, and then you have another bit that does something else, you could compartmentalize them into circuit boards. Just for a bit of organization, you can configure them and add ports, so I could conceivably get that to look almost exactly like this. One other thing to note is that object boards do have a self port up here. So in the same way that the self chip inside of the board will return a reference to the object, so does the self port outside it. Like if I hover over this, it'll say button because it's returning this button here, and then I could take a chip to like set button text outside it, and I could wire that in, and it would know I was talking about this specific button.
Yep. All right. So now if we go in to this button, by using your edit tool, you can edit your button and look inside of it, or look at this board. It's kind of blurry, but these two chips here are events. You'll see there's no port going into it. It's only an output. The thing triggering this to go off is when this one is pressed. You can see it's event receiver pressed, and this one is event receiver released. So this will go off when it's released. You have a question?
But I want to share my event receiver. Something someone messed it up. But, you know, it has this and that. I was checking.
So this button is this thing is synced, so
That's
it's going to
needed
cause
CPU.
some bugs. But we can take a look at this right after. That's pretty cool though.
Yeah, we'll do that in a minute. Going back to this, you'll see there is a self chip. This also has no input. It's just an output to get data. This is specifically outputting the button. Like if you were to hover over that, it's a button. It is this button right here. And this is like we'll saying the self chip. This also outputs the button. Now, if we edit a beacon, you'll see it's slightly different than a button.
The reason we're showing this on the screen, by the way, is because only one person can open up an object board at a time. So like if I were to open it up, no one else could see it.
Yeah. So you'll see in here, pretty much all of these chips have something going into it. None of these are events because there's no real way for like a player to directly interact with a beacon. Like how you can click a button, you couldn't click a beacon. You have to set like stuff on that beacon with chips. So in here, we have connected to the board this execution, which is then going into this chip, which is beacon set enabled. And this here is true. It's really blurry, so I'm sorry, but that is true. And you'll see here it is referencing the beacon from this self chip. The self chip is outputting the beacon. And when this runs, it is getting the beacon and setting it to true. Now, all this stuff is inside of the board doing different things, and you can tell what they're doing based off of the name. But you don't actually need to be inside of an object board to set stuff on an object. So if we go over to this beacon again, and I go into my palette, I can look up, what's the chip in there? It's set beacon enabled. One second. All right. So if I get a set beacon enabled, I can place it right here. And you can see there's nothing connected to this. If I were to run this with the execution, nothing would happen. I would actually get an error because it's not hooked up correctly. Now, if I wanted to make this beacon turn on, I would connect the self of the beacon, which is right here, like that. And you can see this is now connected to that chip. Then I can set this Boolean to be true. So now it says true on there. And if I hold down on this with my maker pen, then let go, it'll run that chip. Separately, I could hook it up to the button. And then when I click the button, it turns it on. When I release it, it turns it off. So you'll see this system here is doing the same thing as just connecting it on the object board. So does that make sense how that works? Yeah. Will, do you want to explain how like variable hierarchy works?
Like in the boards?
Circuit boards, yeah.
Yeah, sure. So I told you earlier that if you have a variable and then you have another variable chip of the same name and of the same type. Notably, if they're different types of the same name, they're also different variables. But if you have two variables of the same type and same name, then if you update the value in one of them, the value on the other one will also update because they are referencing the same value. They are the same variable, like fundamentally. This is mostly true. There is a case where it is not true. If you have, for instance, first of all, just like these chips you're all seeing here, these are considered chips in the global graph or the global scope or global context or whatever. Like their global values, they're not inside of a board, either a circuit board or an object board. They're just out in the room. If you have chips here and you have two variables at the same type and same name, those will be the same value as we have seen. If you have two variable chips of the same type and same name that are both inside of a circuit board or inside of the same object board, that will also be true. They will be the same value. However, if you have one variable that is at the global scope of a certain type and name, and you have another variable of the same type and name that is inside of a circuit board or object board, for instance, that will actually be a different variable, even though they're otherwise the same, because variables do not copy over, like they do not share their value with other variables of the same type and name across circuit contexts. So if they are in different levels of circuit boards or whatever, they will be separated. You can also have circuit boards within circuit boards. You can have circuit boards within object boards. Note that in rooms 1, at least, you cannot have object boards inside of anything else. This does change in rooms 2. You might see that in the coming months. But you can have nested boards that goes like deeper. And this still applies where object or variables do not share values with other variables unless they're in exactly the same level of board.
Yep. So should we give them something to make, or go to lists, or go to like class 2 stuff?
We still got to cover lists, right? So I guess we should probably do that.
Yeah, although I feel like we should explain math or Boolean chips so they can make like a clicker with the variables.
Is that class 2?
Yeah.
Okay, how about we go over the specific parts they'll need once we get to that?
Okay, so you're saying lists?
Yeah, that sounds good.
Okay. All right, you can do what a list is, and then I'll do the chips.
Sure. So everything you've seen so far is just regular values. Like if you have a float, it's just one float. You wire it up into a port, which takes one float. For each of these types, however, there is currently only one other type that uses that type, which is a list. A list is pretty much what you would probably intuitively expect it to be. It is a linear sequence of items of a given type. Note that if you have a list, like for instance, you could have a list of type float, and in that list, every value inside the list must also be of type float. You can have lists of 0 elements in them. They still have a type even though nothing is in them. You can have lists that go all the way up to 4,096 elements. This was 65 recently, but it was just increased quite a bit. So now you can have thousands of items in a list. Yeah, and you can operate on these lists different ways. You can add items to them. You can remove items. You can check if a value exists within a list. So I'll show you some of the main chips that you use to work with lists. Probably one of the most common ones is list create. So this takes a few inputs. We saw this one earlier. A few inputs of type any, and once I hook up something to that list, it'll become a list of that type, whatever is connected to it. And once that happens, if I were to grab like an int port over here and just hook that up, you'll see they have all become ints. So that means this other one that's not even connected, this is also an int port now. So if I were to try to connect another port of a different type, it wouldn't let me because it's integer. However, if I were to disconnect this one and then connect another type, it would then switch over to that type, and it would give me a list of that type. This chip is kind of interesting. You can configure it, and once I configure it, there are options to add and remove ports. So you can have, I think it's something like 65 values on the list create, and these are just regular ports, so you can hook up whatever value, either a hard-coded default, like we were seeing earlier, or some sort of computed value that you get from other circuits. And this will give you a list. This is just one port, even though it has a ton of values in it, or at least potentially thousands of values. It's just one port because it is an entire, you're not passing like a sequence of values, you're passing that entire collection of values as one object, which like goes into other chips. So if I were to take this and wire it to list get count, for instance, this chip will tell me how many elements are inside the list. So right now this is like 7 ports. If I were to take this list and pass it in here, this would give me 7. I hope it makes sense that it's an integer. You can't have like 5.5 items in a list. Also, you reasonably cannot have negative values. It's just 0 to 4096. There's a few others. There is a list insert. First, let me talk about list add. Actually, I guess a little bit simpler. So you'll notice that these list chips have execution ports on it, and you have execution ports when you want to change something in the room. This includes lists because lists are objects. So normally you'd save it into a variable, and then when you add an object, that list has now been changed. It now has that new value in it. They're not sort of just like transient values like integers or whatever, where you're just passing them around. They don't really exist somewhere. If you're like dealing with the list, you'll usually save it in a variable. Notice that if I were to take this list create chip and then I add something to it, I add a new value to it, and then I check the list get count, the count of the list will actually not have gotten any bigger. And that might seem really confusing. And generally, that means you have a bug. So it's understandable that doesn't make any sense. Because the way that you would normally do this is you would store it inside of a variable. So conceivably, you could take like a list create, wire it up into a list integer or whatever variable, and you would store it in there, and you would change the values in that variable. The reason if you don't do that if you add a value and then you get the count that it doesn't get any bigger, is because the way it works is, so I have this list create chip and I add a value to it. So you have this new list and you've added it to it, but that list doesn't actually, it's not like stored anywhere. So like as soon as you do that, it just goes away. Like the list gets deleted off of your computer. And then when you go to get list get count, it will create a new list exactly the same as what came out of your list create the first time. So it's not actually changed. So if you want to make persistent changes to lists, do it in a variable is the main point here. There's a few more chips here. List insert. This is very similar to list add, except you give it an index. This is an integer because lists are ordered. So the very first element will be element 0. They don't start at 1, they start at 0. So as you do more math, it's kind of nice that they do start at 0 instead of 1, even though it might seem kind of confusing at first. But make sure they start at 0, and then all the way up to however many elements you have, and then -1 because we start at 0. So that takes an index. So if I give it 0, it'll shove the new item up at the top. If I give it something like 4, it'd insert it around like here. By the way, when I pointed this is just like a visualization of it. It is a list create chip, so it won't actually like change that. And there's list set element. This is kind of similar to list, as if you like removed an item and you added a new one back where it was. It just changes the value at the certain index, like at the given index. List get element, this does not have an exec because it is not actually changing the list. You're just accessing data at a certain index out of the list. So if I give it like 0, it'll give me the first element in it. If I give it like another value, it'll give me whatever value is in the list at that point. If you try to give it either a negative value or a value that is bigger than the length of the list, it will give you an error, like a circuit error. So because like that doesn't really like make sense. You can't get an element that doesn't exist in the list, and then it'll just like output the type. You'll see that these are white ports. They're any. So when I assign the list, like for instance, let me make this an integer list again. This is now an integer list. So if I hook this up to the list get element any, it'll now know that the output is an int. So it is able to like dynamically infer what type it should be based on what it's connected to. Cool. Any questions about that? Yeah, what's up, Crypto?
This isn't really related to this, but are we gonna like make our own like things with them after?
Yeah, so the whole like structure of the class is we go over like we teach you how the things work, so we go over the chips, and then we'll probably do like an example, teaching you how to do some things, like actually like putting it into practice, and then at the end, everybody breaks off around the room and works on an assignment that we give them.
Okay.
Cool. I think Snug, you could take the rest of them.
Word. You did all these.
Yeah, these ones. Did somebody have a question, Wolf?
Yeah. What's the difference between list insert and list add?
So list add will just always stick it at the bottom of the list. So
Mhm.
you could actually like, if you didn't have a list add chip, like if it didn't exist in the game, you could do the exact same thing by using list insert and then like getting the length of the list and sticking it in the final location or just at the end. It would do the same thing. It's just kind of convenient.
Actually,
Shaking
I
your
don't think
head,
you
Snug.
could. List insert. Oh, never mind. I was thinking of set element. Oh, I'm sorry.
Yeah.
So,
Uh,
I'm so sorry. Correct me if I get this wrong. Sorry, like, correct me if I get this wrong. So, if I plug it into a list with list insert, if I plug it into a list, and the value integer on the bottom, that's just saying like how much said number or something that will be inserted in the list, or how does that work?
Sorry, what was your question?
Okay, so let's say if I try to use list insert in a system, how exactly would that be in use?
Yeah, so I guess if you have like kind of depends on what you're trying to accomplish, I guess, but just abstractly, if you have a list of like ordered numbers, say it's a list of like 0, 1, 2, 3, 4, 5, and then you had a number like -1 or whatever, you wanted to stick in the middle of the list, you would give it the index, a few values in, and then it would update the list so it goes to like 0, 1, 2, -1, 3, 4, 5. And it would update it to take that new value and like shove it wherever you put the index.
Okay. Thank you.
Alright. Alright, let's go over to these chips.
I got a question.
Oh, okay.
Yep.
Go ahead.
If you want to randomly generate the stuff from the list create, you can use the random from list chip.
That's not actually what that does. That's over here, so I will say what it does.
Yeah, we'll cover this in a second.
Okay.
Alright. You can move the camera. Over here, we have list copy. List copy is kind of confusing, although to kind of sum it up, if I have a list variable and then I have a second list variable, let's say this one is just list bool variable 2. Obviously, they're not linked, right? If there's a question.
I know we're not to it yet, but does list concat like merge the list?
List
Yeah,
concat, yeah, that
it gives you a new
that
list
takes
that
two
has
lists
both
and
of
like,
them.
yeah.
We'll get to that in a second.
So list copy, like if I have these two list variables right now, they're their own list, they're unrelated. But if I were to take the output of this variable and then put it into this list like that, these now have the same list in them, and they're like linked. If I were to add something to one of these, it would both get it. Right? I'm pretty sure. So list copy, it means that list copy means that if I take this and do that with it, go through the list copy, these now have the same things in it, but they're not the same list. So if I were to change something on this first one, it wouldn't change on this second. Versus if I do this, they're the same. If I change something on either of these variables, they will both change. Does that make sense what this copy does and why it's even a chip? Okay.
Yeah.
Uh, next up we have list concat. Like they said, you put two lists into it, and it outputs a new list with this one first, and then slapped right onto the end of it, all the items in this list. Yep. Next we have list get all indices of, you know, if we take our bool variable back and plug it into here. Now we could imagine that this variable is full of all true. You know, we have 4 true items in there. And I could be looking for all the items that are false. Now, since this entire list is full of true, it's going to output no items. There's going to be nothing on this output. Now, if I have one thing in there that's false, it'll output as an integer. Think of it as like that integer is the element index of it. So if you were to get that element, it would be the same. So then if I had a list with 4 false items in it, then this would probably output 0, 1, 2, 3 as the list. And then very similarly, we have list get first index of. Instead of outputting a list of all the indices of, this is just the first one on the list. So if I had a list that went true, true, false, 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 so on, and I was looking for false, it would output 3. Does that make sense? Or it would output 2 in my example. My bad. And because that's the first false, even if the rest of them after are still false. You have a question?
Can you like explain that more about what you mean by that? Like, I didn't quite get that.
For this one?
Yeah.
It will just output, like if I have a list, I will just say what I'm looking for on that list. Now, if there isn't a match, like if I have a list full of true and I'm looking for false, this will output -1. And right now you'll actually see it's -1. If you guys hover over, don't click on it, please. But you'll see this list is empty. There's nothing in it. So of course it can't find anything false. So it's outputting -1. But if my list was like true, then false, this would output 1 because the element of my false in there is 1. Does that make sense? Okay.
Mhm.
Next up, we have list contains. If the list has the item I'm looking for, it'll output true. If it doesn't, it'll output false. Right now, it's outputting false because once again, it's empty. Obviously, nothing I'm looking for will be in there. Oh, there's new chips here. Okay. We have list accept. Hold on, I don't actually know these new chips. I'm pretty sure list accept is.
It like removes the bottom list.
All right, wait, hold on.
Check every
Yeah,
This
so
will
list
take the top
accept.
list, and it will
Okay.
remove every value that is in the bottom list that is in the top list. So if you have a list of a bunch of values, in up above, it will look through every value in the second list, and if it finds any of those values in the top list, it will first it will copy the list, so it won't actually remove them from the one you're giving it, but it will return a new list which has every value in the first list, which was not in the second list.
Yeah. Okay. Next, we have list distinct. If you put a list into it, we'll use our Boolean again, and it has like 4 true and 4 false. Once it goes through the list distinct, it'll make a new list, and this one will only have true and false because it will only have one of each element. So if I have matching elements, it'll just get rid of the extra and only have one of it. Then list intersect, I believe, is it will output a new list of every element that's in each of these lists. So does that make sense? Or do I need an example? I got that. Okay. And list union does it combine. Oh, okay. It will put the two lists together, combines them like list concat, except if there's any matches, it won't add that element. It will just right. Oh, no. And it removes any duplicate elements. So it's like a mix of list concat and list distinct. All right. Up here we have list max and list min. Now, you'll notice on all of these, if you hover over the input, it says list any. It can be any kind of list, but on list max and list min, it can only support floats and integers because this is specifically for numbers. So list max will output the biggest number in that list, and list min will output the smallest number in that list. That's it. Okay, next over here. Why weren't these over? Oh, because the remove. All right, I guess. Over here, we have list remove at. You give it an index. Whatever's at that index will be removed unless the index you give it is bigger or smaller than the list, or like a negative number. Okay. List remove all. Oh, list remove item all. You give it a list. You give it an item. Any one of those matching items in that list will be removed. If I had a list of true, 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 false, 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 and I gave it true, it would just be false, false, false. So we get rid of all the trues. List remove item first is same idea, except instead of doing all of them, it just does the first one in the list. And then it even tells you where that item was in the list, even though it's not there anymore. List remove last. It just gets rid of the last item in the list. Yeah. And list clear gets rid of the whole list. If I had this connected to a list variable and there was stuff in it and I did list clear, that variable would be emptied, but so would the list in it. You know, remember what I was saying about having two matching lists in separate variables? If I clear that list, I'm pretty sure it clears it on both variables because it's the same list. Okay, next we have random from list. This was the chip that someone brought out earlier. Yep. So this doesn't generate a random list like you were saying, but rather it will get a random element from the list. So if I had a list that went 1, 2, 3, 4, 5, 6, then this could output 1, 2, 3, 4, 5, or 6. Not all of them. It's just a random one. Each time you run this on the execution, it outputs a new one. Just a random one from the list. It doesn't change the list in any way. List shuffle. You give it a list, and it just changes the order of all the elements in there. And it's just totally random. List sort. This, I think, only works for floats, integers, and strings. If you do strings, it'll sort everything in there to be alphabetical order. If you do a number, it is smallest to largest. But if you change it to descending, it'll flip it. So it'll go then biggest number to smallest, or Z to A, opposed to A to Z. And last up on this section, we have some math chips. These work for actually floats, integers, quaternions, and vectors. So that's lovely, except for list divide. You can't divide a quaternion, and you can't add them. Okay, so list sum, if it is a number or like a vector, it'll just add them up. It'll just add them all together. Same thing for subtract. It'll take the first thing, subtract it by the next thing, then take whatever that equals, then subtract it by the next thing, then the next thing, etc. for every element. List multiply, same idea. It'll multiply the first two, then the next two, then the next two, it just goes down. Then list divide, it'll divide the first two, then divide, etc. It's the same for all of those, but they only support numbers. You couldn't put a string into there because you can't divide a string. Okay, we did all the list chips. So now you guys finally get to build something. There's still like 45 minutes left of class, so you guys will have a surplus of time. So let's give you something to make. Go for it, Will Chill.
We could do an example first.
Oh yeah, word. Should we do an example for lists? Because we just explained all the chips.
The example
Or-
I had in mind wasn't for lists, but if you have one, you could do that if you like.
I was just gonna do everyone who ever clicked the button.
Oh yeah, sure,
But-
sounds good.
But okay. So let's do that then.
Do you have a
And
question,
then
Reg? Sure.
Default. How did you go small?
Oh,
There's
what's
an
up,
S
C?
and I don't know how to go small.
Oh, you
Oh,
just
are you on computer?
go like
We
this,
to
and
do
then you
this
can.
class project. Are we
just
able to
use
ask
both your
y'all
hands.
for
You
help
can go
if we,
big
we
or
get stuck
small.
somewhere?
Yeah, so
Are you
you're all
on
in the
PC?
Discord,
Are you
so
on
you have
PC?
my Discord.
No, I'm on
It's generally
Xbox.
easier to message me there versus
I don't
in
know how to
game.
do it on
So
Xbox,
if you have any questions on how to set something up, feel free to like send me screenshots of your circuits, and I'll tell you what to do or what you're doing wrong or whatever.
Okay.
Yep. Okay. So what I'm about to show you, something to make, and you guys feel free to follow along, but obviously you don't have to. We're going to make a simple circuit that just anytime someone clicks a list, it will then mark down who clicked it. Or wait, Will, do you think I should do who clicked it or the time that they clicked it? Because it's unsynced.
Probably who clicked it if we're gonna use lists.
Okay, we're into who clicked it. So, to start off, obviously we're trying to figure out who clicked a. Oh, there's a question. What's your question? Over.
Are we gonna use a text screen?
Oh, no, actually we're not because we want to use the list. Yeah.
We could though.
Oh,
Like if you were to make this,
are you gonna
that,
put the
that would
list
be a
into
reasonable
text?
thing to use.
What?
Are you gonna put the list into like a text?
No, but you could. What is that
Oh.
noise?
Oh, I don't know.
Okay.
That's my brother doing something. I don't know.
So we're going to take a button because we're trying to figure out who clicked a button. Then I'll just move this to be lined up. And I'm gonna do something kind of confusing, and it'll make more sense once we get to our networking class. So I'm going to edit the object board on this button, and I'm gonna actually remove a chip. So watch this. Man, can you stop screen sharing
What?
for a second?
Oh.
All right, you guys can see what I'm seeing now. I'm going to edit this button, and I'm going to delete if local players should run. I'm going to delete it. So now it is only this event receiver pressed, and when this is pressed, go to the pressed output. Did everyone get that? Do you all see what's missing now? Orbital.
I'm gonna interrupt, but I only see a button circuit and a list player variable 2 circuit.
So you look at the screen over there.
Oh.
Okay.
Huh? What?
So now, did everyone get that? Did you all remove that from your button? Okay.
What?
So
What if I
what
pressed it?
that chip was doing is it was getting the player who clicked that button and then making sure that only that player did the following circuit. Now, for this, we want this list to be synchronized for everyone. Who's talking right now? Speedy.
I think Doom Man is.
It's all good. Just stop. So lists are not synchronized. They're local. So if we wanted everyone to have the same list, we would all have to make the same list or have one person like send out an updated list to everyone else. It's kind of confusing and it's really annoying that you can't synchronize lists, but you know, maybe in the future. So I'm going to take my list variable and I'm going to configure it and I'm going to name this variable to who clicked it. Now you guys make sure that you use a different name. Maybe do your name and then who clicked it or come up with something, but it cannot be the same
Do you have
as
a
mine
question,
because I'm
Holocaust?
linked.
Do you have a question, Orbital?
And oh, you got it. Okay. All right. Is everyone caught up? Who's doing it? Remember, this is a player list.
Orbital, did you have a question?
Like,
Like, if we don't get, are you gonna like, is there gonna be teachers to help us?
So we're going to finish this example up, and then people are going to go work on things. If you have a question on what you're working on, or something you didn't understand in the example, you can come and talk to us once we're doing that, and we'll explain how things work.
Orbitable, or Obo. I'm gonna ask you to go on push to talk because there seems to be a lot of background noise. No problem though. Whatever
Just
you
like
said your brother
audio
was
settings,
doing.
change to push to talk.
Yeah. On your watch, go to settings, go to audio, and then go to push to
I know
talk.
how to do it. It's just like
Okay. Now we're going to take this. I'll just move it there, and we're going to get a list add so that when this button is pressed, it will get the player who pressed it. That's the item we're adding. And then add it to this list. So I'm making that the target list. Now this is pretty much it. This will be keeping track of who clicked it up to like a absurdly large number, like 5,000 something or whatever. Could add stuff to make sure it doesn't go over that, but it doesn't really matter. And you guys don't have to do this, although just to visualize who clicked it, I will get a text and a toString.
Add emojis to it. Sorry.
And then
The toString chip is pretty useful. It like some of the other chips we've seen, it takes any input. It doesn't require a specific type. It works on everything, and then it will take it and it'll convert it into a string. So if you give it a list, well, first of all, if you give it a player, it'll just give you their name. If you give it a list of players, it'll take the name of every player in that list and it'll convert them all and stick them into one big string that has them all separated out by commas. So since we're using a text component, we're going to convert the list into a string because text components only accept strings.
Yep. Okay, so here's our little circuit. I added this if local player should run because this button, this text, my bad, this text is synchronized. And so we don't want every single player in the room setting this text. We only want whoever clicked the button to set it. So this is double checking after. Keep in mind, this is the same chip that we removed from the inside of the button. We just brought it out. So now, when I click this, it says Snug clicked it. I click it again, Snug clicked it. Someone else wants to click the button, go ahead and your name will be added. You can see all the names being added. Now, we're actually probably going to hit a limit pretty soon because a button can only have 512 characters. I keep calling this a button. What is up with me today? This text can only hold up to 512 characters, so this will probably hit its limit pretty soon. But
I think
the
it just
list can hold many. It's already done. It probably wouldn't
Yeah, I think it
end.
just did.
Yeah, it probably won't
That's
end on a
us.
bracket.
God.
Yeah,
But Snug, what
I
if
think
we
it's still
wanted
good.
to only show distinct players that click the button?
Well, that's a good question, Will.
Okay.
So to do that, let's start off by just wiping this
Whoa.
list. We'll get a list clear. I like the singing.
Oh,
Uh,
thanks. That's awesome.
do that just to
I'm
clear the list.
sending
I know it
you
didn't change the text, but
love yous, I'm sending you
don't worry about it.
everything.
And we're gonna take a chip called orbital. I'm really gonna ask you, please mute your mic. We're gonna take a chip called list add if not contains, and hook it up just like the list add was connected. And you'll see now, if I click this button, it'll add my name. But if I click it again, my name is already in this list, so it's not going to add it again. But if someone else wants to click it, you'll see your name will be added to that list. But if you keep on clicking it, it's not going to add it again.
Oh.
And to expand on this even further, we could show everybody who hasn't pressed the button with just a few more chips. So if you, for instance, wanted to make like a ready up system, you wanted to show people getting ready for a game, people who hadn't clicked the button yet, and like the people everyone was waiting for, you could get the get all players chip first. And then we want to do, what is this, list accept?
Yeah.
And then accept that with the people who have pressed it. So all the players in the room, except for the players who have clicked it, and then we're going to run that into the toString. The networking here might be a little bit weird because the list isn't synced, so as I'm making changes, it won't necessarily change. I guess on my end, I'm the one updating the text, so that should be accurate.
Oh, well,
yeah,
this list... Okay, remember how we deleted that chip on the inside of the object board, the if local player should run? That means that if anyone clicks this button, that event is going off for everyone, right?
right.
So, yeah. So this is adding on everyone's local client. However, I don't answer your question. I'll get to you in a second. However, if someone were to join after someone clicked the button, they're not going to have the updated list. It's unsynced. So if one of you guys were to leave and come back, while this list might have all the people who clicked it for me, when you come back, it's just going to be an empty list. But right now, it is synchronized. What was your question, Crypto?
How would you make it so that if you click it, it would show your name, but then if someone else clicks it, it would remove your name and put that person's name? How would you do that?
Oh, well, that's super simple because you don't even need like any of these chips at all. To do that, you would just take a button, a toString, and the text, and then just get the button and set the text. So now it says Snug. Someone else wants to click it, it'll make it your name.
That's actually way more simpler.
Yeah.
That'll actually be
You won't have to, since you're only keeping track of one value, you don't need to make a list of everyone who ever clicked it. You just can directly hook up who just clicked it and then set the text.
That's good. Yeah.
All right. Were there any questions before you move on for something for you guys to build? No questions?
Default.
I'm probably just gonna, I think I already know the answer, but could you kind of like give me a brief like rundown of what happened when I was restarting my internet? Just like super quick.
They try to give you a what?
Where were you? What was the last thing you saw?
I would recommend you just rewatch the video.
Okay.
It's there for a reason. Yeah. Yeah. Hours. Yeah.
Okay, so the main structure of what we're going to do in these classes is we will we'll give the lecture. We'll do an example that's kind of like medium difficulty, and then we'll give you guys something to make, which is hopefully a little bit simpler than the example that we went over. So what you guys are going to make for your first day, it's just a button clicker. So like you hit a button, and then every time you click it, you have an integer variable, and every time you click it, the integer variable is you add 1 to it. So you take the integer variable, you take the value plus 1, and you set that to the new value of the integer variable. And then you display that number somewhere, either on like a text component or in the button text itself.
All right, hold on. Before you go, I want to go over one last thing, which is going to be super important for when you guys are building. We're going to teach you how to organize your circuits, because there is nothing that annoys me more than circuits that are just all over the place, super messy, and like even when you go back like the next day, you're like, what did I just make? You know? So let's show you how to like organize your circuits. Let's say my circuit starts with a button, right? Nothing's going to be before it, and it's going to end with something setting a beacon, right? First of all, there's an issue already. This button is here on this like plane, but then if I come over here, you'll see this beacon isn't even close to the same plane. It is like half a meter forward, right? So if we want to line up these chips, I can just hold down on the beacon chip and make sure that I'm using the move tool and that my snapping mode is surface. And if I drag this chip right next to the button, it'll actually line them up like perfectly. These are now on the same plane and everything. So now they're lined up. I'll move it over, back over here. Perfect. I have room for stuff to go in between. A question?
Yeah, but are you gonna go over the detached like circuit board? Like this setting for
Yeah, I can explain that real quickly. Basically, you configure the object board, and there's a drop down on it: attached, follow, orbit. When it is attached, I think, or orbit, or pretty much everything other than detached. When you move the object, the board will move with it. However, if I were to configure it and set it to detached, I will do that now. Follow detached. It will no longer move with the object. It is now detached, as the name would imply. This can be useful, especially if you have like, I don't know, like a trigger handle with circuits in it, and you're going to be picking up the handle, moving it around, but you don't want your chips to follow it. You just want them to be in the same place. You can detach it. I actually use this a lot. It is very useful. Yeah, just whatever is more convenient for your organization.
Yep. All right. Next up, I'll put down a variable. Now, here's another thing for organization. Name your variables, right? If I have a ton of variables and I want to like look back on it later, it's going to suck for me if I'm like, what did bool variable 3 do versus bool variable 5? Now, if I name this to just on this circuit, it'll make sense to make it on slash, or no, I'll call it beacon. Whoa, my thing was being weird. Beacon on. Boom, beacon on, and I'll sync this variable. So now I know if this is true, the beacon's on. If it is false, the beacon's off. Now I'll take a not chip, and I'm not going to place it like this super far away and then connect it like that. That makes no sense, right? Try to keep everything on a plane, meaning they're like lined up and stuff. So I'll drag it right under my variable and it'll snap into place right underneath. It's lined up perfectly. And then I will take a set.
You're going to want to use surface snap a lot when you place chips. If you are set to surface, and you go to create. When you hover over an existing chip, it will snap, kind of like snap your new chip spawn location in, to be like on the same plane as that chip that you're looking at. Yeah, it's suborbital.
Yep. Keep in mind, you will be graded on this.
If you wanted me to
Oh,
explain,
cool.
I could. If you wanted me to.
That's okay. I think Snug's got it.
This will be important. On your final, one of the grading rubrics is organization. So this is why I hope that you practice this. So then, I'll take a beacon set enabled, and I'm not going to need any of the ports on this beacon, so I'll just configure it and make it. There's a button called delete all board contents, and I'll just delete all of it. So now it's just kind of like just a chip, just a self chip, and I'll just put this right there and hook this up like that, and then hook up the button to it. And you can see this is a pretty clean circuit, and all it does is just toggle the beacon on and off. But do you understand how I organized everything? Speedy, you have a question?
I just want to let you know my headset's on 2%, so I need to charge it.
Okay. Remember, you don't need to remind us if you're leaving early.
Okay.
All right, so now it's time for you guys to build something. Will was saying it. I'll say it one more time, which you guys forgot.
Yeah, so we're going to make a button clicker. You're going to put down a button, and every time you hit it, you're going to have an integer variable, and the value of that variable will increase by 1. So set it to the current value plus 1. So you just hit it, just goes up. And then you're going to show that number. You're going to convert it to text, and you're either going to display it on the button itself, or you could use a text component if you'd like. Doesn't really matter. And then you, pretty simple, just hit it, it goes up. Suborbital.
So a beacon set enabled is optional, but if you're not going to use a beacon set enabled, you would need a what's called an if chip, and you would need to connect a variable condition to the.
You would obviously, if I'm assuming you're talking about what we just made, you would obviously still need a beacon set enabled, because then even after the if chip, you need to set if it's enabled or disabled. But we moved on. So does everyone understand what you have to make? And by the way, fully feel free to ask for help. That's why we're here. Before you guys go out, we're gonna take one more group photo. After this photo, you guys are just totally free to go. But this shows that you guys stayed for class.
Just from the text.
Are my feet in someone's face? Nope,
It's
they're
not
not.
going.
Ridge and Noel, are you here?
Yes, I
Coming
am
to the
here.
photo.
No, it's okay.
No.
Null, are you there?
Okay.
No, it's
Looking good. I'm gonna take the photo. Crypto, come back.
Woo!
All right. Everyone find a spot. And make the button clicker. Teachers, remember to turn on your mic.